I'd like to talk to you about some phase diagram type problems. And what we're looking at here in a phase diagram is we've got pressure on the y-axis, we've got temperature on the x-axis, and we're looking at the different phases or states of a substance at different temperatures and pressures. And not surprisingly, what you'll see is that at high pressure and low temperature, so this would be high pressure and low temperature, water would be a solid, and at high temperature and low pressure, water would be a gas. And all of that it would be predicted based on what we know about water. But what we can do is we can draw this phase diagram, and these lines actually represent the points at which the water will be in equilibrium between two different phases. So this line here represents the liquid-gas phase equilibrium line, while this one represents the solid-liquid equilibrium line. So at this point here, for example, you would expect the solid to be in equilibrium with the liquid, and that would be a certain pressure and temperature that you can read off the graph. Also here we've got what's called the triple point, and the triple point is where the solid, liquid and the gas would all be in equilibrium with each other, and again that occurs at a unique and specific temperature and pressure. I want to point out that this pressure is not to scale. The pressure values here are not to scale, nor is the temperature values here to scale. Alright, so let's see what kinds of questions that we need to be able to answer about this. Well, what we'll see is we've got what phases are present at 200 degrees Celsius and 100 atmospheres, and what we do there is we look for 200 degrees Celsius and 100 atmospheres, and you can see that water would be a liquid at that point. What phases are present at point X? Point X is along the liquid-gas phase interface line, so we're looking at liquid and gas being at equilibrium at this point. The triple point, I've already pointed that out to you. What is the value of the critical pressure? Okay, so critical pressure, that's this point right here. It's actually called the critical point, and at this point it occurs at 218 atmospheres and 374 degrees Celsius. The thing about the critical pressure is that once we go above this particular temperature, 374, no matter how much pressure we put on this gas, it will no longer turn from a gas into a liquid. So even let's say we've got it at 380, there is absolutely no pressure that we could put on this. We could put 500 atmospheres of pressure on it if we wanted to, and the gas would not turn into a liquid. The critical point is defined as being the end of the liquid-gas phase interface line, and it's beyond this point that we can no longer turn a gas into a liquid once we surpass that temperature. This becomes the critical pressure, and this becomes the critical temperature, and you could be asked for either of those. In this case, we're asked for the critical pressure, and that's 218 atmospheres. In this next one, we're given this data. The temperature is held at 25 degrees Celsius. Describe in detail the phase changes that occur as the pressure is increased from this number of atmospheres. So what we do here is we know that we're going to be starting at 0.0040 atmospheres, so that's down here, and we know that the temperature will be held at 25 degrees Celsius. So we're going to be going, and it says the pressure is increased, so we know that this is the direction the pressure will be going. So we start our line here and we move our way up, and we look at the phase changes that occur as we go through that line. So if we start at 0.0040 atmospheres and go up, it's going to start out as a gas, but then at some point it will turn into a liquid. The other kind of question the other kind of question you could be asked would be, what if the pressure was held constant and the temperature was increased or decreased? So let's say we are asked if the pressure was held at 100 atmosphere and the temperature was increased from minus 50 degrees Celsius, what kind of changes would you see? Well, if we started at 100 we started at minus 50 and we held the pressure at 100 atmospheres, you can see that we would start at a solid, and then we'd go through to a liquid, and then we would go through to a gas. So you would just follow the line along, and if you're talking about held at, it means that would be the constant value for that particular quantity.